Welcome back. This is segment 3 of section 1.3, likely our last segment. I can't imagine I'll have even this will be a full video. The last couple were just a tad bit long, but I was trying to complete an idea there. This one will actually be quite a bit shorter. So recall that we were talking about the six basic trig functions, their definitions, and we're looking at some strategies to be able to find the trig functions if we knew something about a point that we could find on the terminal ray of an angle in standard position. Now, in a practical sense, that's pretty useless because the whole point of trigonometry is to be able to, in some sense, measure an angle using some tool or whatever, and then be able to compute, given certain information, different pieces of information about either a circle or a triangle or whatever else. There's certain properties that these things obey, and that's ultimately why we want what we want to get out of trigonometry is the relationship directly between the angle and this point, whereas or this point on this ray or whatever. Whereas when we did this in the previous segment, we didn't really make any reference to the angle at all. Now, the problem is that unlike polynomials and other sorts of functions that you've looked at, there isn't a formula. There isn't like, oh, I mean, there is a form, but God, it's really a mess. But there isn't like, okay, so if the angle, you take the theta and you multiply it by 2 and then take the square root or something. There isn't like an algebraic formula that's simple to be able to say, okay, if you plug in theta here, then you get the sine or the cosine as an output. There are some angles that we can find the values relatively quickly, and then other ones that we have to sort of develop some geometry results to get them, and then that we bootstrap from there. We take say the sine of 30 degrees, and then later on in chapter 5, we look at how we can find, if we know the trig values at 30, well, then we can find them at 15 or, something along those lines where we use it to kind of fill in the gaps. But for now, we don't know anything. Like we don't know at all what the sine of 25 degrees is, other than to pull out a calculator and start whacking some buttons and go, well, that looks right. How would you know? So we'll investigate those kinds of ideas in subsequent chapters. But for now, what we can do is we can look at a pretty simple way of finding what the trigonometric values are for the 4 quadrant angles. So without getting too long-winded here, let me shift over to the document camera, and I'll kind of walk us through this, because it's not a terribly complex idea, but there's a little bit of a trick in here. So this again is section 1.3, and I believe we're on page 5 now. Just make sure. Okay, so page 5. So how about, can we find the exact values of the 6 trig functions for quadrant angles? Remember, the quadrant angles, remember that kind of strange, quadrant angles aren't actually in a quadrant. But these are the angles 0, 90, 180, 270. And if, remember, I said maybe it wasn't last time, it was the time before that, but I said that if it's a coterminal angle, that doesn't really change. It doesn't change the value of the trig function, so it's not really relevant. Well, obviously the answer is yes. But let's look at, for example, let's let theta equal 0 degrees. Now, just consider that for a minute. That's not really sort of a traditional geometric angle, but Let's just kind of draw it over here to the side, kind of a thumbnail. So that means that any any points you pick P out here, because it, Q is on this line too, but it's not really important. P will be equal to, well, it'll have some X value because P can't be O. They have to be distinct. So it's going to be on the positive X axis. So there will be some X value, which is positive. And notice to be on this, to be on the X axis, the Y value has to actually be 0. Right? So point P will have some X coordinate and it'll have a 0 value for Y. Now, what does that make the R value? Well, R is going to be equal to the square root of X squared plus 0 squared, which happens to be equal to, and here I'm going to be really careful, because it turns out that if X, because in some of these cases, X is going to be negative. And so maybe I'll take one more step here. There was this little kind of crazy thing that they did in probably in an intermediate algebra where they said, well, if you've got this situation where the index on this radical is even and you have a variable raised to the same power, that you have to use an absolute value. Okay? That's sort of a weird, subtle point, but it is actually true. Since we're doing this sort of algebraically, it turns out that R will actually be equal to the absolute value of X. Now, since in quadrant, since we're talking about an angle of 0, X is already positive. So this happens to equal X. So let's review. X is some positive number. R is equal to X. Y is equal to 0. So the sine of theta, or sine of 0 degrees, because now we actually know what it is Y over R. Well, Y over R is 0 over X. Well, 0 over anything that's not 0, because X has to be a non-zero number. So 0 over some number, not 0, is just equal to 0. Now, what does that say about cosecant? Well, you can't, if you try to take the reciprocal of 0, this will be 1 over 0, but 1 over 0 is not defined. And so this turns out to be something that is just undefined. There isn't a real number that does this. And so I use this UND to mean undefined. And this will come up a lot. So make sure that you understand why that works, right? If you're trying to divide by 0, you don't get 0 or some other kind of crazy thing, and just you don't get anything. You don't get a real number. Now, what about cosine? Well, cosine, remember, is equal to X over R. But notice that's just X over X, which as long as X isn't 0, which it's not, this will just be equal to the number 1, right? And so secant, which is, sorry, not theta, secant of 0 degrees, which is the reciprocal of 1, is just equal to 1. So it turns out for this one value, they're actually equal to each other. For other angles, they're really not. I mean, there's 2 places where they're equal. Now, what about tangent? Well, tangent of 0, well, that's just going to be Y over X, which is the same thing as 0, as the same thing as actually sine, right? It's 0 over X, 0 over X. It's 0 over some positive number, so it's equal to 0. And so much like cosecant, cotangent of 0 is also undefined. And you got to be careful. I really shouldn't be using equal signs because that doesn't make any sense from, from a purely mathematical standpoint. You should just simply say cotangent of 0 is undefined, but it's fine. We're not being too rigorous here. Okay, so what about 90 degrees? So let's do the same sort of thing. Theta equals 90 degrees. Well, here we have kind of a similar setup. Here's our coordinate axis, and Q is over here. Q is irrelevant, but P is over here, and P has a coordinate. Well, in this case, the X is 0, right? And Y is just some positive value. Right? Y is greater than 0. And so if we go through this same sort of calculation we did here, we're going to get that R is equal to the absolute value of Y, and since Y is positive, happens to equal Y. Right? So now we have X, Y, and R. So X is 0, Y is just some number, and R happens to be that same number. So sine of 90 degrees is equal to Y over R, which is just a number divided by itself, not 0. Some positive number divided by itself, which is just going to be equal to 1. So cosecant, which is the reciprocal of sine, will also be equal to 1. Now, what about cosine? Cosine of 90 degrees? Well, cosine of 90 degrees, remember, that's X over R. So 0 over some positive number is just going to be equal to 0. And therefore, secant, similar to what happened up here, will be undefined. What about tangent? Well, tangent is, remember, is y over x. Well, y is some positive number and x is 0. You can't divide a number by 0 and expect to get a real number. So this ends up being undefined. Now, what's the reciprocal of an undefined number? Well, remember I said that those formulas only hold when the numbers are actually when those angles are in the domain of the functions. It's a fancy way of saying as long as they're defined. So maybe we just go back to the definition of cotangent. I think I missed my 90s here. Okay. So the definition of cotangent is instead of y over x, is actually x over y. And x over y is 0 over some positive number, which is just equal to 0. All right, so maybe everybody sees how this is working. Let's go with theta equal to 180 degrees. And again, I'm just going to draw this. Now, there's the terminal ray is actually coincident with the negative x-axis. So out here is some p-value, which has an x, some x, and 0. But notice in this case, x is actually negative, which is kind of a weird setup. For whatever reason, people get confused by that. So going back to this sort of calculation, remember r is the absolute value of x, but since x is negative, r will actually be equal to negative x, which is kind of an interesting dilemma. So sine of 180, which is y over x, well, 0 over some positive number, right? I mean, that's positive. This is equal to 0. So cosecant of 180 is undefined. And what about cosine? Cosine of 180, and this is where this negative sign comes in. So cosine of 180 is x over r. So some negative number divided by the opposite of that number is just going to be equal to -1. So secant of 180 is going to be also equal to -1. And tangent Well, tangent is y over x. Well, that's a 0 divided by some negative number. It's going to be 0. And similarly, then cotangent of 180 will be equal to, will not be defined. Okay, last one, and then we're done with this section. So let's take the angle 270, and everything is very similar. So note T is down here. P has a coordinate of, well, the x value is 0, and we have some y value, which is negative, similar to what we did right here. R is equal to the absolute value of y, which in this case happens to be equal to negative y. So I think you're kind of seeing how this is going. If theta is 270 degrees, then sine of 270 is y over r. So number divided, negative number divided by its inverse. So this will be -1. So cosecant of 270 will be -1. Cosine of 270, which is x over r, 0 over some positive number, will be 0. So secant of 270 will be undefined. Tangent of 270, which is y over x, so some negative number divided by 0, undefined. And cotangent of 270, that's going to be x over y, so it's 0 over some negative number. It's going to be equal to 0. So let me just kind of summarize there. There is a table in the book that has all these values, and you're thinking to yourself, my gosh, what's going on there? Why are we going through all this? Well, it turns out that one of the outcomes of this class is to be able to know, recall, or be able to produce the exact value of all 6 trigonometric functions for certain angles. And these are what are called special angles, and the quadrant angles happen to be special. So at some point, you are going to be expected to know what these values are. Now you can do them by either rote memorization, you can memorize what the definition is and then think back to these pictures and try to do all this other sort of stuff. We will have better tools at some point in the future, especially when we start thinking about the unit circle. Kind of gives us a little bit of lead in as the values of these quadrant angles. But that's why we introduce many different ways of thinking about these things. But unfortunately, it is one of the aspects of trigonometry that is kind of unusual. A lot of people, when they take math classes, they do not expect to have to memorize a bunch of stuff. They usually think, oh, well, it's just sort of a problem-solving process, right? You know, you try this, you try that, you get the answer. And there is some of that, but there is an awful lot of just rote memorization in trigonometry. So this is kind of the first section. When you start to see this, you have to memorize the definition of these trigonometric functions. You have to memorize the fundamental identities. You have to memorize the values for specific angles. And it starts to become a little overwhelming. That's why we kind of lead into it. And hopefully by the time that you really have to use this stuff for anything major, you'll have that sort of in your memory bank. What I suggest to students every semester is that I say, get yourself a set of flashcards, okay? And on one side have the, like cosine of 90 degrees. And then on the back side have its exact value, and test yourself, because this will make you much more proficient at being able to recall these things. That's one way that you can do it. You could test each other. I know that with sometimes that's not always possible, but certainly you need to practice this, because when it comes time to take a test, you may get a dozen of these, and not just sort of these relatively easy ones that you have to be able to memorize. and recall in a relatively quick fashion. And you know, I've seen a lot of students do really well at that, and then I've seen some students that don't do it at all, and so they will lose large numbers of points on tests because they just simply don't, either can't or won't memorize these exact values. So anyways, just a little word to the wise, get practicing on it now, and it'll save yourself a lot of headache later down the road. Okay, so this is the this ends the material for section 1.3, and I will see you back again for section 1.4.